going to try to get through a little material on 5G, the Internet of Things, and the age of the coronavirus, how the current pandemic may be affecting this. I'm probably going to have to skip through a lot of my slides because I have way too many slides, too much material. And I have done a previous talk, which was about 5G. So the basic concepts may include some repetition from that. Okay, topics to be covered. There is going to be a brief technical description of what is 5G, 5G characteristics, optimizing bandwidth utilization, and further refinements. There are different carriers and different bands. There are 3 main bands involved, and I will talk about that. I may be able to talk a little bit about spectrum reallocation, although I think I might not do that this time, and the Sprint T-Mobile merger and what implications that may have for rural and wide-range suburban coverage where there are single-family houses. There are transmitter and receiver changes, and I'm going to explain why there are 2 names for 802.11ax. It's also known as Wi-Fi 6, and I'll explain where Wi-Fi 1 through 5 went. And something called beamforming. There will be speed and coverage, recent developments in the rollout, where, when, how much it might cost. The costs are a little hard to pin down as usual. I'm not sure I'm going to do anything on the actual devices. They tend to be cell phones right now, and that just changes by the week. There are some Massachusetts case studies for 5G cellular and 1 at least for fixed 5G to the home. We have also some futuristic technologies, satellites and fixed 5G home services. I do want to get a little bit on how Iridium Next and the SpaceX effort, how they evolved historically, because this has parallels to some extent with how we got the U.S. highway system, the interstate highway system. I may be able to get to a little bit of that kind of thing as well. And there is a company called Starry, which is offering fixed 5G to the home. And it really is 5G, although previously this company is notorious for saying they had 5G speeds when it isn't 5G technology. Comcast and Verizon do the same thing. They say 5G speeds because it's 1 gigabit per second. Well, we'll get to just what speed means in terms of 5G and what it doesn't mean. And there are some large-scale applications with the industrial Internet of Things and smart cities. But the only way I'm going to cover industrial Internet of Things, or IIoT, is through its lessons to be learned from the pandemic with the supply chain logistics and impacts on work and impacts on learning. I think since those are timely topics, those are things I really should spend more time on, not less. And then there is public resistance to the new technologies, and some interesting stories have arisen as a result of that. And I may get to a little bit about how the US and Huawei have really shot each other in the foot. And like I say, I don't think I'll get through all possible materials, but the technical parts, I may need a little help from some people. What is 5G? And 5G technologies versus 4G. The core network is still the internet. It still uses the internet backbone. The bandwidth on 4G allows 200 megabits per second. On 5G, potentially it's greater than 1 gigabit per second, and the maximum speed is 10 gigabits per second. That maximum speed is misleading, just as 100 megabits per second is misleading of 4G LTE. Latency is an important term, and we'll try to get to it, and it has to do with how much stutter you get in your videos, how much dropout you may be getting, how long it takes to see video versus audio in what we're doing, like Zoom, any kind of video chat, or Apple FaceTime, to be fair to everybody. And the 5G has less than 10 milliseconds, sometimes 4 milliseconds latency. And that, by the way, is good enough for streaming video, for real streaming video at 4K. The power consumption in 4G for the device is rather high if you're doing data. You may have noticed if you're using 4G LTE data, your phone goes dead really fast. But there's at least 10% more durable batteries with 5G, partly because it is lower power. 5G is something like 10 times lower power at the antenna than 4G. And this also has implications for people who, think that there are health implications to being bombarded by all kinds of electromagnetic radiation. The mobile coverage in 4G is very limited. Now, 5G, how it reaches, the places it reaches, is almost as important as the coverage it can have. And that depends on which band we're talking about. I'll get to that. So we have the evolution of 5G. 1G really never existed. It was just the original cell phones. And John, I'll get to what limited coverage means. For example, there are dead spots in 4G LTE. I have a dead spot at WallX for my service. And if you place the antennas correctly, 5G can help a lot with these dead spots. And also the low band has ways of dealing with it. And I'll get to a little bit more of that. So we have 2G and where it brought us up to, GSM, GPRS, and Edge technology. Edge was a big thing a few years back. 3G continued Edge, and it did code division, multiple access, CDMA, and all kinds of other nice technical stuff, which brought the speeds to 2 megabits per second, which at that time seemed good. But if you try to stream a video or do a video chat, not so good. 4G is not as much about the technology, but rather the requirements set forth by a governing body. And that led to the standards that we now have. And the standards were quite complicated, which made it difficult to, just a moment. It made it difficult to adopt 4G for many carriers. Okay, the result of the dead spots is, it's true. It is not just a result of not enough antennas. And yes, you do drop back to 3G, but even my 3G will cut out at WallX. So 4G LTE was introduced. It stands for long-term evolution. It's not a technology so much as a path followed to achieve the 4G speeds. It was a complete redesign and simplification of the 3D network, which is now being phased out. So there are defining characteristics of 5G. There need to be 1 million connected devices per square kilometer compared with 100,000 per square kilometer we can now do with 4G. There should be end-to-end latency of 5 milliseconds or less. That's 10 times less latency than 4G networks. Reliability of 99.9 to the third decimal, which is a lot better than current technologies as well. In fact, it's probably better than some home internet over the wireline. Service deployment of 90 minutes. That means once you have the infrastructure built, you can put out a new network or a new provider in just 90 minutes of setup. And there's also network slicing, which allows you to do something really neat, which I'll cover in the next slide. There's an energy efficiency that is 10% of current consumption. I said it uses 10 times less. And I'll get to the chat later. Network slicing. Network slicing means the ability to create new subnets for specialized uses, such as to say for first responders or internal organizational networks. So how do we achieve these goals? Well, Verizon says that to hit these benchmarks, assuming you can, where 5G infrastructure is fully deployed, they'll have to deploy a lot more small cell sites, which I'll describe, and they'll have to string a lot more fiber to connect them. Remember, Verizon is big on fiber optics. And that's Steve Blum, the CEO, talking about that. So, what's Wi-Fi 6? Wi-Fi 6, otherwise known as 802.11, which I have the decimal in the wrong place, AX. Most of us have heard about 5G, the soon-to-be adopted standard, but that's just half the picture. For the future in-house, for our routers, there's a new technology, Wi-Fi 6, or AX. There's a weird naming that happened. Wi-Fi 6 was adopted in place of 802.11ax by a standards organization. You won't hear much about Wi-Fi 1 through 5 because these were already named by the 802.11 standards. They're the A, B, G, N, etc. And Wi-Fi 6 is about improving the network when a lot of devices are connected. When Wi-Fi 5 came out, the average US household had about 5 devices in it. Now, on the average, they say households have 9 Wi-Fi connected devices. I guess they have a lot of teenagers or something. And various firms have predicted that with the Internet of Things, consumer IoT, connected homes, will have hit 50 on the average within just several more years. That's the average household. Okay, Wi-Fi 6 is not about absolute speed. It's about managing multiple connections. And we'll do more on Wi-Fi after we go over which bands are being used. And I'm going to get through the bands and then I'll check the chat and see what we've got. So we have a 5G bands cheat sheet. I'm going to read from here that the low band has longer distances and better coverage over wider areas, but it has lower data capacity and hence slower speeds which are comparable just barely to 4G LTE. There's a mid-band, which is a compromise between the low band characteristics and the high band characteristics. Low band also can penetrate buildings and materials better than high band. High band has the best download speeds, but it has poor building penetration. And I think my illustration might have something about that. I'm going to switch shares. Yeah, cell phone antennas are capital intensive, much less so for 5G antennas than the traditional 4G. So the spectrum, licensing. I'm going to try to get this, there it is. If I'm not on 150%, here we go. The low band, as you can see, 700 megahertz seems to be a popular area in the low band. That is close to where T-Mobile and Sprint have been doing it for wide area coverage. And the mid-band is sub 6 gigahertz. The sweet spot there is around 3.4, 3.5 gigahertz, and then there's another one around 4 gigahertz. And you'll notice we just jumped up from hundreds of megahertz to several gigahertz. So it's quite a bit of a jump in terms of the frequency. That means you can get a lot more data throughput. And then you have the millimeter waves. These are the ones that are being used in specific hotspots in cities. And that's something that doesn't carry very far. And when we do beamforming, I'll talk about just how fast you get a fall off in your signal. There's also some further refinements, TDD and FDD. TDD is time division duplexing. All of these are duplex technologies. They tend to be full duplex. There's time division duplexing and there's frequency division duplexing. I'm just going to show here that you have intermittent sending and receiving with TDD, And you have to have some guard times in between, other technical details. TDD alternates transmission and reception, and the time slots may be variable. It's used in Wi-Fi networks and in some 4G LTE networks. Some use FDD. The communicating parties cannot tell that the transmissions are intermittent. For FDD, we have dedicated bands. That means you're going to use 2 channels at once. And that usually means more than 1 antenna, although there are ways of doing it with a single antenna. There are 2 separate wireless communication channels on separate frequencies, one for transmit and the other for receive data, with a guard band, which is a frequency gap in between. And that's an important thing. FDD is used in microwave links, like to your pharmacy or to offices. It's used in millimeter wavelengths, which are used in similar situations, and also satellite uplink. I think millimeter wave and microwave are both used in satellite television currently, although that may change. Some 4G and LTE networks also use TDD, some use FDD. You need good filtering and duplexers and shielding in order to avoid interference between the channels. And this tech goes hand in glove with MIMO and MU-MIMO, and I'll explain those. In most parts of the world, all the previous and current mobile network generations were based on FDD, full duplex. But there are huge spectrum allocations for TDD, especially in the US and China. This is why a few years after LTE networks were started up, that'd be about the early 2000s, they were started mostly as FDD networks, but later we saw them change over to TDD variants because there's just so much more spectrum available. And there's been even more former television spectrum allocated over to wireless technologies. And these are some of the reasons why. So with 5G NR, which is new radio, first it uses 4G LTE as an anchor. And then 5G is currently download only, but it will eventually piggyback on top. Just like now you have 4G that drops back to 3G. And for the networks deploying 5G in the 3 gigahertz range, which is mid-band, TDD is really the only option. And it's the only option for millimeter. At this point, I'd like to check the chat and see what I've got. So stories about 5G not safe for users, I will get to at the very end. Capital intensive cell phone antennas, much less so for 5G because they are smaller antennas. What frequencies are used by microwave ovens? Microwave ovens can interfere with some home routers you might know in the 2.4 gigahertz range. But here we're above that range, so we're not really going to have that problem. That's something that was taken into consideration early on. Again, yes, around 2 to 2.4 gigahertz gets interfered with. Duplexing is about supporting bidirectional communications, correct. Without duplexing, it's like the old walkie-talkies where you're going to have a delay, and you're going to notice the delay between sending and receiving, and you have to say over, and then wait, and then that's like the old satellite reports they had on the news where they would have to pause up to maybe a minute or two, and you'd see nothing but dead air. While they were doing this, this had high latency. So that's how that comes through. Now getting back to what I'm doing. I'm not going to go into OFDM and OFDMA very much, just to show you, currently there are 64 subcarriers per 20 megahertz channel. And now you're going to have many more. AGN and AC has this many on the top. AX and this is also true of the outdoor technologies with 5G, has probably about anywhere from 4 to 6 times the number of subcarriers, hence number of channels available, multiple users simultaneously. Now we get into MIMO. MIMO stands for multiple input, multiple output, and it refers to the way bandwidth is broken up by a router and pushed to the individual devices. Most routers use single user MIMO or SU MIMO, and multi-user MIMO would be able to break up the bandwidth into separate individual streams that can be shared evenly no matter what the application, and can be shared simultaneously, more simultaneous users. There's also something called massive MIMO, massive MU-MIMO. And what I am going to do is go over to an illustration. First, this is your single user MIMO. Wait a minute. There, that's your single user MIMO. And it serves just one device at a time, so you have to have something known as a token ring. And you have to alternate which device is using it. And that's sure going to interrupt your video and your game playing pretty badly these days. So you go over to multi-user MIMO, MU-MIMO. And then you can have people connected simultaneously, and every provider is trumpeting how their network can handle this. Well, really, it's your router that has to be able to handle it more than anything else. And notice there are multiple antennas, whereas there's only 1 or 2 antennas on routers that don't use MIMO. So you may end up having to update your router if you want to make the best use and if you have a lot of users in your household or a lot of IoT devices, each one of which needs to communicate in a timely and orderly fashion. So MU-MIMO, all right, MIMO is designed to avoid latency and dropouts. MU-MIMO reduces lag and latency and also allows even more devices. Edge processing at the antenna site outdoors will allow even lower latencies, and massively MU-MIMO is the array that is used to allow even more users simultaneously. So edge technology is just something from 3G, and it really isn't something that's important enough to cover here. So beamforming. This is a way of both overcoming obstacles and getting a better signal to the places where people are actually using their devices, also known as hotspots. In a normal router or antenna, you are sending out in a roughly circular pattern, but it does not have to be spherical. Home routers actually radiate downward more than upward. So here's a hint. If you're not getting good coverage throughout your house and you have your router in your basement, it needs to move up to the attic. And that sometimes solves the problem right there. That's both building materials and the fact that the beam actually points a certain direction. It is a directional beam. But anyway, you have the law of inverse squares, which means you'll have a fall off that is quite rapid as you get farther and farther from your access point. This is why people in their houses have additional access points, repeaters, which introduce more latency, and lag. Lag is different from latency, but they're delays. And there also is something known as mesh networking, which uses multiple access points tied together. And that means you have about equal access to your hub from any particular point. IoT devices use a hub, and they use a sort of a mesh network. But with beamforming, you will have certain places where the beam is directed. And because it's directed to these places, you'll have really good reception there. But if you move just a little bit to the side or in between, you've got very little or nothing. Indoors, that's really not much of an issue if you have specific places where you use your devices. But if you're outdoors, that can create dead spots. And it can also control hotspots for subscribers so that you only get access where the vendor wants you to have access. Say it's store Wi-Fi. You only want people who are using your store to be using your Wi-Fi. You don't want the whole neighborhood using it because that's costly. So here's the outdoors case. And this is a node, and it's forming its beams so that you get the building, which would be for fixed wireless. Or you can get indoors with the low band or the mid band. You can actually get indoors cell phone coverage with 5G. 4G doesn't do well indoors. But with the high band, it'll reflect off the glass and you're not going to get anything at all. And so now you have a hotspot in front of the store, a hotspot in the park. But it also means people on other areas, if they move outside of these beams, these formed beams, there will be a fall off which can be so dramatic that you drop back to 4G or even 3G. And this has been demonstrated in previous tests, which I covered in a previous talk. So how effective is beamforming? The promise of 5G gains with lower latency, etc., requires the ability to have these beams steered. And they can be steered in real time as well. So you can adjust where the beams are going. Beam-centric optimization is another term they use, and it's required to quickly identify and fix root causes of any issues you get. For example, somebody's not getting a signal where they're supposed to. And this did happen in early tests. And how fast will the 5G be? At this point, I'll just check and see if there's anything here. The beams are constructed at the antenna, and they are, the beam forming has to do with the hardware that's in the antenna. It can, I don't have exact details on the technical specs of how these antennas are constructed. That was either in a previous talk or else one of our other group members talked about how antennas are constructed and how you do that for radar. And the same principles would apply here. So we might want to reference a different talk on that. So, and I'll take one more chat before I go on. Oh, your home router is actually more effective than the outdoors beamforming, because even though your home router isn't very flexible, you can position it and you can turn it and you can change how the antennas are oriented. And that also affects how the beamforming works. And if you're a real tech genius, you can actually adjust it through the firmware in some routers. Some of the fancier routers are even programmable for this sort of thing. Tech companies are promising a lot with 5G. And we've already talked about 10 gigabits per second versus 100 megabits. And at these speeds, current home cable would face serious competition from fixed 5G. And let's see what else. The load time, faster, what the results are, faster load times and improved responsiveness when doing just about anything on the internet, whether it's playing a video or a game or contacting your device, resetting your home thermostat from outside, or even opening your garage door, things like that. Specifically, it promises 4G has 20 milliseconds latency. 5G can have 4 milliseconds latency, which is good enough for home internet for most purposes. And 5G base stations run full duplex, and we have discussed the benefits of that. But switching between transmitting and listening modes is what most of the previous technology was doing. Now, RootMetrics did studies of several cities, and I apologize for apparently some of the data in this table having been scrambled by RootMetrics or whoever picked up this table. But what we've got here in one column is the percentage of the city that's covered. Washington, D.C. has a very small geographic area, so its coverage is likely to look higher in percentage, but it's not really that much more acreage or square miles. And Indianapolis was one of the early places to get 5G cell service. and we have some speeds, and they compare between the cities. And the fastest download speeds have been very disappointing in some places. And I think we are talking about certain areas of Chicago and Indianapolis where they did not have the beams formed correctly. And people were complaining that they weren't even getting 4G speeds off of their 5G. 5G is download only. The uploads are still over 4G or earlier. So the real world testing has produced a real mixed bag of results. In my previous talk, I went into greater detail about this testing. Verizon 5G users continue to see the fastest average speed in 2020 and the peak download speeds, but there's very low availability, and we'll discuss where and when. And T-Mobile and AT&T are delivering 5G at only 4G-like speeds that are less likely to impress consumers. And this doesn't seem to matter which band they're using. They've still got slower speeds. So the results are a bit different from last year, but not that much different. Areas of coverage have been increased, and there are several Boston and Eastern Massachusetts towns and cities where 5G cellular is being rolled out. And T-Mobile and Sprint, well, that's low band. So again, the speed isn't as good, but they are able to make huge claims about covering 200 million households and covering 6,000 cities. But the speed they're getting doesn't even compare with 4G in some cases, in some areas. But they do have the coverage, and that's the advantage of going with the low to mid band. So that's all about outdoor cell phone service. If we get to it, we'll do Starry, which is doing what will be 5G wireless to the home, but previously it has not been 5G. And AT&T's 5GE or 5G Evolution is also not 5G. T-Mobile has also been advertising 4G LTE as 5G speeds, but it's not 5G technology. And just for comparison, here's what's happening internationally. You'll notice that the UK has faster 5G than we do, thanks partly to a company called Huawei, which the US doesn't want to do business with anymore. And then there's Spain, Australia, Kuwait, Switzerland, South Korea, and Saudi Arabia. So internationally, they're ahead of us in many countries. Part of that has to do with politics, but part of it has to do with how complex our regulatory structures are. Not all of that is political. Some of it is practical. We have a larger area, and we have not more devices. We do have more devices than any place other than China and maybe Japan and South Korea. Per person, they tend to have a lot of devices, more so than even we have. But in any event, here, the Wi-Fi that currently exists is faster than 5G, which is one reason we don't have wireless home internet services yet. But that's going to change. So here's some companies that have some various things rolled out. Verizon has fixed and mobile 5G in several cities, although the 5G in both is limited. AT&T has mobile 5G in hundreds of cities. T-Mobile and Sprint have their low to mid-band 5G. US Cellular has 5G cell service in Iowa and Wisconsin. C Spire has 5G services in Mississippi. Charter Spectrum Mobile is providing 5G service this year. Comcast Xfinity is rolling out 5G services. And they've been advertising and trying to get me to join. Simple Mobile is another one, which is piggybacking on T-Mobile's network. They are a third party. And Nextech also is a third party. Nextech is rolling out their 5G services. US Mobile, which I use, is a third party repackager. And they are also trying to get me to move up to 5G. And so we have, there are more details here about exactly who and where, and I think I'm going to skip through a lot of this because this is a lot of detail and we're not going to have enough time for this. But AT&T is remarkable in that their initial rollout, like Verizon, was to particular businesses, and consumers only recently started getting them. By the way, you do need a special phone or a special device to be able to use 5G. It isn't going to happen with your existing phone just by updating your SIM card. And the phones can be pretty expensive. They tend to be very high end, and they are often tied to a particular carrier because the 5G methods that are used by particular carriers may differ from carrier to carrier. And T-Mobile and Sprint and what they're doing. And it's about as fast as 4G. And other companies which I have named. I don't know what 5G FWA is, which C Spire is using. So maybe I'll find out. And all the way down through Comcast, Charter, and US Mobile. Fixed 5G home internet services are mentioned for several companies, but none of those companies really specializes to the degree that Comcast, RCN, and Verizon have with their wireline services to the home. The exception is a company called Starry. And Starry does operate in some areas around Boston. And my city, Waltham, is considering Starry for a future rollout of 5G technology once we get the infrastructure built. So before we move on to the 5G, fixed 5G wireless and satellite internet, let me see if I can pick up that chat again. Okay, I can, yes. All right, let's see what we've got. Okay, Wi-Fi extenders for 5G, they do need to be a new type. You will need new equipment. Greater Boston area, what I'm talking about is limited spots in downtown Boston and the Fenway area. And Medford is also doing experiments and a little rollout. Millimeter waves, yes, are affected by rain as well as vegetation. Mobile virtual network operator, yes, they're a repackager, and they piggyback on someone else's network. And yes, I will have my slides available. Thanks, Steve. Unlocked 5G devices. Yes, there are some, but the carriers really push their own phones because they tend to pair their technology to the phone. In the sense that the phone tends to be optimized for whatever band they're using, and it tends to be tuned to whatever they're doing. So usually they will try to get you to use one of their phones. But I think there are two, at least one from Samsung, and Apple was talking about putting out an iPhone that is 5G capable. So those may come in both locked and unlocked. So like other, all right. For home internet, a fixed antenna is installed on your house, similar to how a satellite dish might be installed. This antenna then creates a wireless net connection with a nearby tower. It doesn't pair to a particular tower. It's just if you have a neighborhood antenna, there's probably only about 3 that are within range. And so if one goes down, you can probably pick up a signal from another, but it won't be as fast. But it still might bridge you over. So, like other wireless connection, 5G does operate on the radio spectrum, but in a very different way from the past internet options. So rural areas might be better served by satellite, and let's see here. And satellite internet has undergone some improvements. Let's take a look at what Starry does. Starry has recently bought some extra spectrum in the 24 gigahertz region. That's pretty high frequency, which means it operates more like the millimeter waves. And the network they already have an existing network which was not 5G. And it was offered just as wireless internet. And it passes through households in Boston, Washington, D.C., Los Angeles, New York, several other cities. Its first launch was in Boston. And the company sells what they claim to be 200 megabits per second download speeds at $50 a month. They don't say how many customers they have, but that's not a real big issue. Today, Starry uses shared spectrum of the 37 gigahertz band, but the 24 gigahertz band will be unique to them, and so they will own it completely. So they might be able to reach 40 million households. That just means their signal will be available. It doesn't mean they'll be there. They have to get the cooperation of a building. If they want to put in an apartment building antenna, they have to get, they don't really want to do anything low density where the houses are farther apart because they won't be able to turn a profit. And there are limitations on how many customers each Starry antenna, each Starry transmitter will be able to service. And it's much lower than with traditional cable nodes. So that's why they're focusing on multi-unit buildings, because they only need a single antenna to antenna connection. And still, there's a lot of buildings in a lot of cities that Starry will be able to reach. So Starry can't provide service if they don't get access to the building. I would hope that wouldn't mean that your building would have only Starry as their option. I don't think they do. I think they just offer it as an alternate option. So you still have your Comcast, your RCN, whatever's available. In my building, we don't have RCN, but we do have Verizon as well as Comcast. So the technology that Starry uses, because it is the millimeter waves, the buildings are too far apart in rural areas, so it doesn't work well with that. But the point to multi-point design enables the company to provide gigabit capable coverage, though they're not up to gigabit speeds yet. And they're thinking their cost is about $20 per house that is hooked up to their network. And then they publish their average speeds all the time. And again, it's in the 200 megabits per second with latency of about 12 milliseconds. Not quite what you'd expect of 5G in terms of latency, but they're getting pretty close. And here's a nice illustration of how it all works together. And to do that, I'm going to minimize our Zoom window so that I can show. You have your Starry beam, which is the sending and receiving station. And it's just one antenna. You don't need a whole forest of lamppost antennas scattered throughout the neighborhood for this to work. You just have one building, one antenna. And it's a common shared mast antenna with the receiver on the top. So it's supposed to be less intrusive. So come on down there. Now, so there are probably going to be different price ranges and different speeds, just like you have with current providers. No data caps at the $50 rate. And $50 per month, by the way, is quite a bit cheaper than standalone internet is at these speeds with wireline services like my Comcast. It would be several times that much. The company also promises to follow net neutrality, and that's a big issue these days. It isn't going to throttle content based on who's sending it or the type of content, and they don't. They don't need to, as long as they have very few subscribers. Once they get up to bigger numbers of subscribers, we'll see if they follow through on this promise. But at least they have a commitment to it. Well, so did Comcast at one time. Okay, I'm going to look into the chat now because we're about to move on to some more exotic technologies and a historic lesson. Okay, so what we've got here is, what is the interference between 5G and GPS? To my knowledge, 5G works better with GPS than previous generations. And one reason it has to is the IoT involves navigation and vehicle-to-vehicle communication. This is the industrial IoT, IIoT. And if there's time, I'll get to that a little later. Between 5G and GPS, there cannot afford to be interference. GPS has to operate in real time with very low latency, and there is some edge processing that happens with regard to GPS. So you really need to keep the bands from interfering with each other. This is one reason why not the entire spectrum is being given over to 5G. So that's also why the FCC is taking a long time to get this rolled out. And 1 gig is 1 gigabit per second, and $70 per month from RCN for that speed. Good. I wonder how many. Anyway, it's probably nice. Susceptible to bad weather. I think Starry is somewhat susceptible, but in their particular band, they've chosen places where bad weather is much less of a problem, where vegetation is much less of a problem. They don't need building penetration. And because they don't need good building penetration, they aren't worried as much about obstacles. And they go from the tops of buildings where there aren't very many trees up there, except maybe a rooftop garden or two. So here's an exotic one. Anybody remember Iridium? Shake your head yes if you do. That was a satellite telephone service, which was rolled out by Motorola. And it was called Iridium because of the number 77 on the periodic chart. But they had to pare that back to 66, so I don't know why they didn't rename it to the other element. But anyway, it was supposed to provide global coverage. But did you ever see one of these Iridium radio phones out in Mongolia? How huge these things were and heavy. They were like the 1980s bricks that we used to use for cell phone service, and about as reliable. The other problem was it cost over $350 a month for a subscription. Some news organizations could afford that, but very few companies and individuals caught on. So it was supposed to provide overlapping coverage with other satellites so that you would never be out of signal range for cell phone service. And in this case, today, that would be for internet service. So the phones were big and heavy. It was expensive. The service never really caught on. And as cell phone coverage expanded, the market shrank even further. The U.S. military considered reviving the project, but most of the original Iridium satellites have since been brought down in these spectacular fireballs. However, the idea that you need global coverage and that you use satellites to do this found a new use. The idea, which has since been taken up by Elon Musk and SpaceX, was driven in part by a terrible tragedy. And that was Malaysia's flight, whatever number it was, but the Malaysian airline crashed, Flight 370. And no one ever figured out for sure what really happened, but they lost the plane from radio communication, probably by deliberate sabotage. And then they were not able to track it by satellite because it went over an area of no coverage from land stations. And to this day, the wreckage has not been found, we think. So a change was made. A new project called Iridium Next started launching satellites for aircraft tracking and for other reasons why we might need to track in the civilian sector. The military has its own satellites, And that's one reason they didn't pick up the original Iridium. But Iridium Next is supposed to give the kind of coverage that will prevent a repeat of a Malaysian airline problem. And if an airliner is in trouble and loses all radio contact, they will be able to keep some kind of ping as to where they are, so that they might be able to be rescued, or rescue teams might make it out there. So now we have Starlink. And these are these 60 satellites, 60 times 60, 360 satellites that Elon Musk is sending up there, because now we do have, we think, a market for satellite internet. But today's satellite internet is really garbage in terms of speed. Like Hughes, anybody ever had Hughes? They just unreliable, weather interferes with it. Satellite TV is similar with these receivers, and the dishes are big and they look really ugly on houses. 5G uses much smaller dishes. The antennas are much less conspicuous, and it will give coverage even in parts of Africa, Asia, Central Asia, which just simply can't string fiber optic because it's just too remote. So Starlink aims to provide low-cost, high-speed broadband connectivity to customers globally, with the specific goal of offering service to customers who don't currently have reliable or quality access due to their remote location. And by the way, remote location can include parts of Vermont and New Hampshire. I know some people up there who just can't get reliable internet or cell phone coverage, and maybe this might help. Pricing has not been announced. However, the public beta will begin 3 to 6 months into 2020, not long from now. And we've all been told to look skyward to see these launches and the satellite trains. Really interesting stuff, some of it. So let me check once again with the chat before I move on to the rollout in Boston, because this will bring me, there we go. Yeah, there are pieces of wreckage from the Malaysian airline flight, and Element 66 is dysprosium, which I guess wasn't as poetic a name as Iridium. So anyway, Verizon has announced that Boston area customers will now have access in the Fenway neighborhood. And a few days later, it said it would be rolling out low-band 5G across eastern Massachusetts. Waltham is currently in negotiations to build out infrastructure to make this happen. And Medford is already doing it. Verizon has rolled out its 5G service in a total of 18 cities in the United States. Boston was included in the latest batch. Verizon's 5G ultra-wideband will allow those with compatible devices to stream 4K movies with virtually no buffering to your cell phone, and video chat with near zero lag, so you can zoom from your cell phone, and quicker downloads and more responsive gaming, and eventually augmented reality so that you can walk out into traffic while you're playing Pokemon. So let me get on to the next slide. Because you have to live and work close to a small cell in order to have coverage, the coverage starts off to limited patchwork of streets. And the infrastructure may be built out over the next few years. Lexington may also have things going on. I'm not privy to your technology committee up there, but some member of the group is, I believe. You might have a talk about that one of these days.
Excuse me for just a second. Ken Pogren, who is a member but rarely comes to the meetings, is the chair of what's called the CAC, the Communications Advisory Committee. And that is a group that reports into the selectmen that tracks a variety of networking type issues and problems and deals with the providers coming into town.
Yeah, it would be nice to get a report on how the 5G build out is or is not happening in Lexington. Because I know in Waltham we're very close to doing it. And it's going to be
the... ask if he can give us some insight.
Yeah, we can see if we can do that. And the way we're doing it in Waltham, and probably you'll do it in Lexington, is with neighborhood antennas. But also, we have in Waltham big buildings, so we can use the building tops. And businesses are going to love that. In other words, yes, they will like it because they can now do business to business and they can serve their employees. And there's a lot more that employees are doing remotely these days. I hope we will get to it, and we may. And AT&T will offer, AT&T is saying they will offer broader coverage, but they acknowledge that their 5G service won't be as fast. I'm guessing they're using low band for AT&T to get neighborhood coverage, whereas downtowns are getting their millimeter wave treatment. So the 5G network will be significantly better than 4G services, offering lower latency, massive connectivity, and faster speeds. It is expected to be complete in Boston by the end of the year. So the coverage map and so on and so forth. There are going to be swaths of eastern Massachusetts, Providence, and southeastern New Hampshire eventually. And that's not too many years off, we think. Communities are already negotiating about it. AT&T will offer millimeter service to consumers also. Businesses already get that service. Verizon is offering 5G services in Medford. The short-range mobile sites known as small cells are installed on existing utility poles in Medford. And I'm going to show you what these look like. This is pretty much from my last talk on IoT. These are your neighborhood cell towers now. This on the left is an actual lamppost. And you're wondering perhaps about radiation in the neighborhood. 10 times less power means many times less radiation exposure. And again, the law of inverse squares. The farther you are from a lower powered antenna, by far less radiation. And sometimes they're in arrays that are on top of actual towers, if you have a taller light pole, and you might have something that looks like a bread box or a pizza box. And then down at the base, there is an edge processing unit, which will process the signal or pre-process it before anything goes to a central hub. That reduces latency, and if you're doing smart highways, it's vital to be able to do that. So I asked, has anybody heard about 5G build out? John Rudy says we might have a person who can talk. And then the coronavirus pandemic. This has changed a lot of things about 5G, IoT, IIoT, and logistics. You do not have to have 10 times the number of towers for the 5G neighborhood as for the previous. And so what? You've got lampposts at least on every street corner and mid-block. So that's enough. It does cover. It covers a few hundred feet to a couple of 100 yards, depending. I mean, if you live up in Prospect Hill in the Highlands in Waltham, there might be some topography issues, but it's pretty good. The power of the receiver, their power does not have to be as high as the 4G towers. It is significantly less, and I think it is, in fact, 10 times less at the tower. Your device may be a lot less. And your device only has to be able to contact something that's like a few hundred feet away, as opposed to being perhaps up to a quarter mile away for current technologies, maybe farther. The coronavirus pandemic may fast forward 5G adoption. Remote work is one of the main drivers. There's a need for 5G technology like never before. Verizon issued a press release recently stating the demands of bandwidth had increased 75% in 1 week as people went to remote work and Zoom meetings like we're doing today. FCC and the federal government are trying to accelerate deployment in urban and rural areas. And yet, our federal government decides this is the moment to pick a fight with Huawei, which is the world's leading supplier of 5G hardware parts. And they decided not only to pick a fight with Huawei, but also to pick a fight with our European and East Asian and Australian, New Zealand allies to try to force them to stop doing business with Huawei when they have already been doing build-outs with Huawei hardware. You know, rip it out, put in something new. In Europe, they've got Ericsson and they've got, what's that Finnish company? But there's another company in Europe, which also do Nokia. Nokia and Ericsson both do pretty much as good a job as Huawei, but some of their parts are manufactured in China. The coronavirus has disrupted supply chains, and we're going to get to that just briefly. So the global pandemic has forced a supply chain slowdown, and that's affected all computer and technology assembly, and it may delay the expansion of 5G. So there's supply chains. And just before I go into supply chains, there might be something interesting. Is there a penetration problem with 5G? It depends on the band. Millimeter 5G, which is the best for throughput, has very poor penetration. You open a glass door in a city and you lose your cell phone coverage. Close the door and you've got it back. Go behind a tree, it's gone. Come back from behind the tree, it's good. Beamforming is another issue. Get to the edge of a beam, 5G millimeter wave falls off very rapidly. But the lower band or mid band fall off much less rapidly as you get outside of the sweet spot. And they do have good building penetration. You even have cell phone service inside your house, inside your apartment with the low to mid band. And that mid band is what T-Mobile is doing. So yes, that's a valid question. Now, ways that the coronavirus could affect the world supply chains. There will be a need for quicker decision making, and 5G will reduce the need for all operations and tasks that don't require a high skill level, say in warehousing and in transportation. This is both a jobs destroyer and a jobs creator in the STEM fields. Workers may have to retool. 5G technology will enable optimum performance across all stages of the delivery process. Predictive analysis tools will detect errors, identify the shortest possible delivery routes, and send notifications to staff when maintenance is necessary. Has anybody been inside of Stop and Shop in places like Watertown, where they have that little robot that goes up and down the aisles and it beeps at you, and occasionally the store intercom has a message, cleanup needed in produce, cleanup needed. They are cutting down on cleaning staff needs by having the robot find where the spill is. And this is, in warehouses, they have much more efficient robots. For example, Amazon has warehouses that are almost entirely robotic. And yet, the coronavirus showed us, even where you have fewer workers, there can be problems resulting from staff getting sick. So, we need for the 5G technologies to be IoT ready. And we're talking about the logistics companies. We're talking about tracking inventory, predictive analytics, tools for location management, and drone delivery systems. Everyone can think of examples of these, including Amazon. You have precise item tracking. So you're not as likely to get the wrong item delivered to the right place, or the right item delivered to the wrong place. And you can do inventory. Theoretically, this means that if you have a surge in buying, like we had with the hoarding and with the panic buying, if you have intelligent algorithms, you could actually do real-time adjustment of just-in-time inventory, and you could pre-position inventory the way Amazon has been doing for a few years with their warehouses. And they can predict if you're going to do a repeat order to a particular location, especially for businesses. I have gotten a few products from industrial suppliers, and they do, in fact, do the repeat ordering thing with their businesses. So vehicle-to-vehicle communication is not only happening from from communication devices, radios within the vehicles, but also to roadside and smart highway antennas. And this would not have been possible with previous technologies, because when you move from a cell tower to another cell tower, you momentarily lose communication. And you certainly would not be able to watch television while in a moving vehicle. But you can do that with 5G because the latency is so low and because you have this instantaneous handoff that theoretically can happen. There's supposed to be increased productivity, and companies with supply chains that already use robots will see noticeable improvements in their performance. So this is supposed to lead to increased customer satisfaction because you get things faster and you get more accurate orders, and there are fewer shortages in your orders. Drone-based delivery systems, more control over inventory. Theoretically noticing when demand is surging, but as we have seen, the algorithm is only as good as how it is programmed. What we've seen with the supply chain in the coronavirus pandemic is that the algorithms failed. And they failed to predict what would happen if workers got sick in the warehouses and factories, so that production shut down, and so that traffic had to be rerouted. When that happened, they didn't have sufficient depth of coverage. They didn't have sufficient backup. They weren't able to do failover, as it is known in business, switch from one location to another. And it's kind of hard to move livestock, hogs, from one area to another. So they couldn't necessarily get the hogs to the meatpacking places that were open and that had capacity. Whereas the places that were nearby and you could easily transport, everybody was getting sick. So we have route optimization and better location tracking. And we have, there are additional reports on how the supply chain infrastructure is affected. Now, let me see if there was something important coming through in the chat on this, because there are a number of these. Kiva technology with Amazon uses robot-to-robot communication. Correct. They even have robots repairing and partially building each other, assembling each other. 5G can't solve manufacturing delays as opposed to distribution of already manufactured. This is true. Like if in China a factory is shut down, you will not have your parts available. And robot viruses. Yeah, fun. Okay, robot attacks. Stop and Shop is, yeah, they are experimenting. I have already said that. Okay, more power is adaptively used by devices when the towers are more distance. Yeah, there is adaptive use of power in phones and in the towers. Mostly in the devices. Will 5G latency be good enough so we won't notice the difference in our face-to-face? Yes, 5G would improve Zoom tremendously. And I might have a little time to cover how this affects education. And that's why I'm going to try to find out what's on my next slide. I'm going to skip over this because of it talking mostly about food waste being reduced and lean inventory and the panic buying. And we still have human workers. So 5G, IoT, and industrial IoT will also rely on big data analysis. They have to be able to collect large amounts of data, and then they have to analyze it. Just as we're doing in healthcare, this will also have to happen for supply chain logistics. And this will help improve the algorithms. Like Alexa, these systems can learn with AI. And the more AI they have, or the better AI they have, the better they'll be able to learn. So will this result in a change in where and how we work? And the idea here is that companies have to take a closer look at how they communicate with employees the patterns of communication, and how to keep employees productive when they're working at remote locations. And the cloud platforms which support business apps have got to be secured, and they have got to be the right kind of apps to keep the workers productive, so that they're not flailing around with some unfamiliar or counterintuitive kinds of apps, of business apps, that actually hurt their productivity when working from remote locations. And this is about business teams. Okay, so the coronavirus outbreak will put remote work strategies and contingency plans to the test. It's a test of whether companies can truly build a digital workforce where employees can work from anywhere. And in some industries, obviously, you can't. And in some jobs, you can't, which means other things have to happen. Now, there is something controversial about education, a lot controversial about education, and that's this remote learning we just went through. Remote learning, we might have gotten it wrong completely. One educator is arguing that we shouldn't have tried to get all students to do the remote learning thing, that there was only 15% of the actual instruction time that was actually lost to the shutdown of the schools this year. That time, and teacher time and administrator time, might have been better used focusing on special needs students and keeping them from A, falling behind, and B, providing for their needs. And also low-income students who don't have internet connections would require different kinds of learning plans. So there were experts who weigh in on how the sudden forced adoption of technology-driven instruction will affect the well-being of students and professors alike. They were talking university, but this applies at other grade levels as well. Part of what you do depends on how long you expect remote learning to have to be used. If it keeps on for several semesters, then it will gut higher education's finances, and some difficult choices are going to have to be made. Humanities and the arts might suffer as core subjects and STEM subjects get more funding and attention. So given the equity issues that are worsened by the recession that just happened and is happening, open education resources and open access publishing, that's open source, might be something that would benefit and would triumph. Inequalities might drive the use of technology in different directions. And research at many institutions is falling behind as a result of the pandemic, because research scientists and engineers aren't able to get to their work. They aren't able to be in their labs, and they aren't able to use their equipment in some places. So the recommendation in the lower grades especially is that faculty not rely too heavily on synchronous video conferencing like Zoom, so as not to disadvantage students whose internet infrastructure is poorer. They could use something like YouTube or public television and get their lessons in an asynchronous way, which does not chew up the bandwidth as much. Seminar-style classes, but this means teachers and professors need to learn new ways of teaching, and they need to learn new ways of presenting, just as we're learning with Zoom. And this is an interesting issue. So one of the worries is that you have to maintain the communication between students and faculty, or students and teachers, or between special needs students and the people who help them. And parents have been saddled with most of this responsibility, and that has turned into a horrible experience for most families. And the worry is that this will turn out to be a horrible experience of online learning for many, and they will never want to do it again. We're hearing all kinds of commentary about how we never want to do this again. And that's just a terrible tragedy, because there's so many good things that have been learned and that can be learned. And there's so many good learning ways. We've talked about these MOOCs online and how good and how not so good they can be. They have both advantages and limitations. And pressures could mount for medically unsafe, premature openings and a return to normal education where everybody's in class every day. And there could be a disaster that would follow from that. So we need to be more creative than just opening Zoom rooms or just posting stuff in, I don't know what the LMS is, but somebody else does, especially when so many of the students at the university don't have reliable internet access. And this is even more true in the lower grades. So I talked about special needs students and MOOCs. Sports and social experiences are also missing from online education. And this, during a prolonged period of social distancing, could affect how social development happens. And that's an important part of education too. Technology, great as it is, does not have all the answers for educating kids in a time of pandemic disease. I think this is going to be near the end of where I will get today. Because the next thing is community resistance, but I'm going to check the chat before I get into that, because that will be my concluding thing. Because this is going to be some of these myths about health effects and about various other conspiracy theories. And it's kind of interesting stuff. Okay, now we will go a little ways into chat. Younger kids' special needs generally need more human personalization of instruction and coaching. True. Teachers' unions have also taken a stake. They both don't want to go back and get sick, but they also do want to be able to have more face-to-face contact with students. And this is a balance that has to happen. It's a real problem. Learning management systems, thank you, Peter. Instead of using asynchronous video conferencing for less economically advantaged students, the nation can and should invest in distributing the advanced equipment to all households. Well, the question is, do you give them a Chromebook, or do you give them access to computers at a centralized location, which we can't do now? Or do you let them in a few at a time to some of these computer workstations? Or in the future, are we all going to have cloud desktops in the cloud, and simply offer the connection and a simple device to get to your cloud desktop, to get to your cloud classroom? And then, of course, the excuse of my dog ate my homework is my internet went down. So, yeah, it can happen. And so there's much more that could be covered, and we could do a whole breakout session about the coronavirus, education, and work. So what I am going to do now is give you a few crazy little stories about what happened. This isn't crazy, but in Northern California, some towns are making ordinances that would make the neighborhood cell sites, they would ban them from residential areas, citing the supposed radiation hazards and the supposed cancer clusters. Residents in several Western cities have lobbied for restrictions. 4 states, including New Hampshire, have proposed bills that would mandate studies on the health effects of 5G radiation. And I'm going to just put in good luck finding those effects. And I'll tell you why later, just a little later. More than 500,000 new cell towers and small cell sites need to be built. Residents can be very unhappy about the appearance of small cell antennas in their front and backyards, in front of their houses. It's the good old NIMBY, not in my backyard argument, because it's going to drop my property values and all kinds of other terrible things will happen. There's an activist group which is lobbying to reduce exposure to the electromagnetic fields. The issue they fight about is the unknown health impacts of 5G radio frequencies. They also fight on non-health related issues like fees, which are not equitably distributed currently. It's not a good investment to allow a company to come in and build out the infrastructure right now. So that needs to be adjusted. Property values and who has the power to zone and regulate the infrastructure. Local municipalities have just had themselves cut off at the knees in terms of their ability to regulate, because some of the federal rules from the FCC have eliminated a lot of options that municipalities had and have for regulation. Still, both Lexington and Waltham will be debating this and will be negotiating with our providers. And by the way, because this is wireless, you don't have to have monopolies or duopolies. You can have multiple providers, just like you have on cell phone networks. Somebody can piggyback on somebody else's infrastructure and pay them a fee. But you have to figure out how to do that. So in the meantime, Verizon is finding new ways to appease residents by installing smart poles. And they designed a standalone pole that houses the wireless small cell equipment, and it's completely hidden inside of the poles. City of Denver has approved some of that in both 4G and 5G. And I want to close with just a few of the wilder conspiracy theories, and then I'll check the chat and we can throw open. If we want to stay a little longer, we can, but if we don't want to, we can end pretty close to here. There's a relatively new theory circulating around the UK and Western Europe that 5G could have been a cause of the coronavirus, and that the first cases of corona were supposedly happened at the same time in late 2019 that 5G was being rolled out and the towers were being built. Well, that's not true, because radio waves have no proven impact on the virus's development or spread. It's spread through the air, through droplets. 5G has been under development for years, long before the coronavirus jumped species to humans. And last but not least, China isn't using millimeter waves for 5G networks. It's using sub-6 gigahertz waves, which fall into the mid-band spectrum. These radio waves have all been around for years with 4G towers. Of course, that won't stop people from talking about cancer and cell phone usage. So conspiracy theorists have gotten so radical, they're starting to burn down cell phone towers in England. They've burned down 5 of them already. And terrible, terrible stuff happened. 50 fires. The current wave dates back to a particular group in England and also a particular Belgian doctor who suggested a link between 5G and COVID-19. So older variations were circulating around before that about cell phone radiation causing cancer. That was based on some studies which we now know were flawed. And theories gained momentum, and we had Woody Harrelson, whom you may remember from Cheers, who shared a video claiming that people in China were taking down a 5G cell tower. And that wasn't really true. There was some kind of an upgrade going on there. And none of these theories has any basis in peer-reviewed scientific or medical studies. Daily cell phone usage linked to the cell phone being held to your ear and cancer clusters are largely a myth. And the power lines are not causing autism or any other disease or infirmity that we know of. To gain an understanding about how and why people get these theories and see patterns in data which actually have no statistical patterns, you might want to check out Neil deGrasse Tyson's book, The Null Signal.